Hello everyone, this is Sir Hill Bonsuelo Jr. from SDOQC New Era High School. Welcome to another Math 21 with Sir G. Another grade 10 lesson to be discussed. Without further ado, join me. Alright, in today's lesson, we're going to discuss the deciles for group data. So if you could remember, we've just finished discussing quartiles for group data. So deciles for group data are used to divide the distribution into 10 equal parts. These are denoted by d sub 1, d sub 2, up to d sub 9. The computation is similar to the median and quartiles. Here is the formula. So d sub k is equal to the true lower limit plus a quantity of your k times n all over 10, since we are going to divide the group into 10, minus the cumulative frequency divided by the frequency where the lower limit is located, multiply to the class interval. Again, d sub k is the deciles, where k is numbers from 1 to 10 or to 9 rather. Our L is the true lower limit, and again is the sample size. Capital letter F is our cumulative frequency. Small letter f is the frequency where the true lower limit or the lower limit is located, and I for the interval. Okay, let us have some exercise. So in here, guys, we are going to find the values of decile 1, 5, and 9 from the given frequency of the scores in algebra class with 50 students. And here are the scores. So if you could notice, the class interval is equal to 5, and here are the frequency of scores. Alright, and we're going to deal with the cumulative frequency. Again, we simply copy the first value or the least value on the frequency. Then let's look at the left side one step higher, then take the sum of those numbers. So 4 plus 5, that would be 9, and repeat the process until we end up to the top, no? So 9 plus 12, that would be 21, plus 10, that is 31. Then 31 plus 11, that would be 42. Alright, plus 6, that would be 48, and plus 2, that would be 50. So the sample size and the last value on the cumulative frequency must be equal to 50. Alright, so I hope that is clear. So let's continue. So using the decile formula, so our k here, since we are looking for decile 1, our k is 1, so d sub 1 equals to the lower limit or the true lower limit plus a quantity of n, so your sample size over 10, minus the cumulative frequency divided by the frequency where the lower limit is located, times the class interval. So let's solve for the value of n over 10, and since our sample size is equal to 50, so 50 divided by 10 gives us 5. And take note that the cumulative frequency should not exceed the value of kn over 10, so that's why our cumulative frequency is 4. And of course, we look to the left one step higher than the cumulative frequency, where our frequency is located, alright, with the lower limit, and this is the lower limit, 20. And to get the true lower limit, of course, we always subtract 0.5 to the lower limit, so we arrive at 19.5. And from there, we're going to plug in 19.5 to the lower or the true lower limit, plus of course the value of n over 10, which is equal to 5, minus to your cumulative frequency, which is equal to 4, all over the frequency where the lower limit is located, which is 5, and times the class interval 5. So let's simplify. bringing down 19.5 plus simplifying 5 minus 4, that would be 1/5. Alright, then 5 divided by 5, that is equal to 1. So 1/5 times 5 is equal to 1. So 19.5 plus 1, that would be 20.5. So therefore, decile 1 is on the 21st position. Alright, so take note, we are looking for the position here. Alright, so let's proceed in getting the position of decile 5. Alright, so again, in here guys, our k is 5, that's why we have 5 here. Alright, so decile 5 is equal to the true lower limit, sorry for that, then plus a quantity of your k is 5, so that's why we have 5n here, all over 10, since we are going to divide the entire group into 10, since this is a decile, minus your cumulative frequency all over the frequency where the lower limit is located, then to be multiplied to the class interval I. Now let's now get the value of kn over 10, or 5n over 10 in this case. So plugging in the sample size, which is 50, so 5 times 5, that is 25. So therefore we have 250 all over 10, so that is equal to 25. But take note that the cumulative frequency should not exceed kn over 10, so therefore we're going to use 21 instead. And we're going to look on the left, one step higher than the cumulative frequency, and there we can get the frequency. Alright, the small letter f here, that's why we have 10 there. And of course, we can locate the lower limit, then of course we have to subtract 0.5 to get the true lower limit to be plugging in to our formula. So decile 5 is equal to the true lower limit, which is 29.5 plus a quantity of, again plugging in the value of kn over 10, which is 25 in this case, minus the cumulative frequency 21 all over the frequency where the lower limit is located, which is 10, and to be multiplied to our class interval, which is equal to 5. Now bringing down 29.5, then plus simplifying 25 minus 21 gives us 4, of course, over 10, then multiply to 5, and that is equal to 2. So 29.5 plus 2 is equal to 31.5. Therefore decile 5 is located at the 32nd position. I hope that is clear. Alright, so let's proceed on the third one. In here guys, we are looking for decile 9. Alright, okay, again just like what we did on the first two exercise. In here guys, our k is 9, that's why we have 9 here, that's why we have 9n over 10 there, then minus the cumulative frequency all over the frequency where the lower limit is located, no? And multiply to the class interval I. And of course, the next thing to do is to get the value of your 9n over 10. So again, plugging in the sample size, which is 50. So 9 times 5 is 45. So 450 divided by 10 equals to 45. And again, our cumulative frequency should not exceed the value of kn over 10. So it should not exceed 45. So that's why we use 42 instead. And again, looking one step higher on the left, okay, and we will get the frequency, okay, where the lower limit is located, which is 40 in this case. And of course, we are looking for the true lower limit. We have to subtract always 0.5, then we will arrive at 39.5. Then we're going to plug in that value on the formula. So d sub 9 equals to 39.5 plus the value of kn over 10, that is equal to 45, and the cumulative frequency in this case is 42, to be divided by the frequency where the lower limit is located, which is 6, multiplied to the class interval 5. Then, simplifying, bringing down 39.5 plus 45 minus 42 is equal to 3 over 6 times 5. That is 1 half times 5. So that would be 2.5 plus 39.5. So that is exactly on the 42nd position. Okay, therefore, decile 9 is at the 42nd position. Hence, alright, so to conclude, decile 1 is 21, decile 5 is 32, and decile 9 is 42. I hope you got all of these, but if not, you may always pause the video, rewind, rewatch, then try to pick your pen and paper, use your best scratch paper, then do some exercises, until you feel confident that you can do this alone. Alright? Okay. At this juncture, I guess it's your time to shine. So it's your turn, guys. You can do this, of course. And here is your problem. So below is the frequency distribution of ages of 50 faculty members. So let's find decile 2, 6, and 8. Alright, so of course, you have to complete the table for the cumulative frequency. Alright, so I'll give you 20 minutes for this. So please pause the video for 20 minutes before playing it again. Alright, so I'll be here. And your 20 minutes, guys, is gone. So let's check your work. So for number 1, decile 2 is located at 30th position. Alright, so that is 29.5 or 30th position. And our decile 6 is located at 37th position. Alright, and our decile 8 is on the 40th position. So to sum up, decile 2 is on the 30th, decile 6 is on the 37th, and decile 8 is on the 40th. I hope you got all of this. Again, if there are some confusion, you may always pause the video, then rewind, rewatch, then practice using your pen and paper and scratch paper. Okay? Alright. So until our next Math Kwentuhan, this is Sir Gil Valenzuela Jr. of New Era High School. Ciao! See ya!